Hello everyone, and welcome to this example recording on nodal analysis. So in this question we're going to be completing the following. We're going to be using nodal analysis to determine the currents I1, I2 and I3. So that's the currents flowing in this branch, in the middle branch, and in the branch on the extreme right hand side. Alright, so we know that when you use your nodal analysis, you're going to assign a particular node to current flow. So let's select this as the node that we'll be working from. We know that the current I1 flows to the left, the current I3 flows to the right, and the current I2 flows down. Further to this, what we can also do is we can decide to switch the position of these two circuits or these two elements. So we can say, just to have a bit of consistency in the circuit, we can say that you have a circuit that looks as follows, where that will be the 12 volts, 4 ohms, 6 ohms, and the 2 ohm resistor and the 10 volt source have switched position. So the currents are still in the original direction. That will be I2, I1 and I3, but we've switched the 10 volt source and the 2 ohm resistor. You're able to do this because it's a series circuit. It doesn't change the current that's flowing in this circuit. Right, so let's apply KCL in this circuit. So with this KCL, what we're going to do is we're going to have an unknown here, which we're going to call V, and we're going to use KCL to determine that V value. And with this V value, we should be able to determine I1, I2, and I3. So KCL, node V. The current I1 will be denoted as, or rather the KCL will be I1 plus I2 plus I3 is going to give you 0. In place of I1, we're going to say V minus 12 over 4. In place of I2, we're going to say V minus 0 over 6. And in place of I3, we're going to say V minus 10 over 2. And then we can expand this equation. So we can say the common factor there, we can say the common factor between all of them, 6, 4 and 2, we can say is 12. So 4 to 12 will be 3, so that will be 3V minus 12 times 3 will be 36, plus 6 to 12 will be a factor of 2, so plus 2V, plus 2 to 12 will be a factor of 6, so it will be plus 6V minus 10 times 6, which will be minus 60. That will give us 0. Right, and if we simplify this, we've got 3V plus 2V plus 6V, so that's 6 plus 5V, which is 11V. And in terms of the separate numbers, we're going to have 36 and 60. So minus 36 minus 60, so this will be 60 plus 36. Therefore, V is going to give you 60 plus 36 will be 96 divided by 11. And this gives us a value of 8.72 volts. Right, and now that we have that, we then can say that we know I1 is then going to give us V minus 12 over 4, so that's going to be 8.72 minus 12 divided by 4. Or rather the current I1, and that gives us a current of negative 0.81 amps. What does this mean? This means that the current I1 must be flowing in the opposite direction, right? And we should expect this because current, according to passive sign convention, is usually from the source around the circuit to the negative terminal of the source. So we should expect current to flow in this direction, and the sign tells us that the opposite direction that we've chosen is actually the direction that we should have chosen. So the current flows in a clockwise direction and has a value of 0.81 amps. Right, in terms of I2, we can say I2 is V over 6, so I2 will give us 8.72 divided by 6. And that gives us a value of 1.45 amps. And I3 is going to give us V minus 10 over 2. So that's going to give us 8.72 minus 10 divided by the resistance value of 2 ohms. So that's 8.72 minus 10, and we divide this by 2 ohms, and it gives us a value of negative 0.64 amps. And similarly here, we should have an expectation of current. We know that current goes from the positive of the source around the circuit to the negative of the source. So current we should expect to be flowing in that direction. The current that they want is in the opposite direction, and this is why the current we've obtained is negative. So these are the values for current I1, I2, and I3 using nodal analysis. Thank you for watching this video and enjoy the course.